All right, so here we go. Consider the Earth and Moon. Draw a picture to the right. Well, I don't have the right, but we have the Earth and the Moon. I tried it with the typing thing, and it just didn't work out. Sorry. We know the Earth exerts a gravitational force to pull the Moon. Oh, sorry. We need a direction in there. I can't read. Pull right on the Moon. Okay, so it's pulling the right on the Moon. The effect of that is the Moon falls to the Earth. It's not going to hit the Earth because it's moving at such a fast speed that it's going to come down, and Earth is moving. It's going to fall, and then just continue to orbit around the Earth. If there were no sun, then eventually the Moon would fall and land on the Earth, collide with the Earth. Wouldn't actually land on there. But because there's a sun which is pulling the Moon greater, the Moon is actually falling towards the sun because the sun's winning that tug of war. So every year the Moon gets a little bit further away. I believe it's 4 centimeters a year. The Moon gets further away. The reaction is the Moon exerts same type of force, gravitational, pull, opposite direction, left on the second object, or in this case the first object. And the result of that is we experience tides. So here's the picture. The Moon is pulling on the Earth, and this pink area, that's what's called a tidal bulge. For different pictures, you can look it up, but the shape of the Earth actually changes because of this. So on one side where the Moon is pulling, you're going to see this bulge in the Earth. Tidal bulge. Getting back to it, a person uses a hammer in order to drive a nail into the wooden board. Consider the hammer and nail. Okay, so we're not talking about the hand in this. A lot of students are going to want to say, oh, well, the person exerts a force on the hammer. True, but we're not caring about that. Our system right here is only the hammer and the nail. So hammer exerts a normal force. Hammer exerts normal force because it's a surface, right? The head of that hammer is a surface. Normal force to push down on the nail. Have I hit all of my main points? Do I have my object? I do. Do I have my type of force? Yes, a normal force. Do I have push or pull? I do. Do I have a direction? Yes. Now, the effect is the nail goes into wood. All right, reaction. We need to have an object. The other thing in this, right? Exerts type of force. Push or pull. Push, push, matches. Opposite direction. Object 1. The effect is the hammer I'm trying to hurry up here. I'm so sorry for the illegibility. Hammer bounces off nail. You've seen this before. You've done it before. You went to Home Depot or whatever. Hopefully I don't get another strike for copyright infringement. You have the surface, and you have the nail, and then you have to hit the hammer. And as you hit the hammer, it's going to bounce backwards. The reason it's bouncing backward is because that nail is pushing back on the hammer. As tiny as that nail is, and as strong as you can slam that hammer down, the nail is always going to respond by pushing backwards on the hammer with an equal magnitude and opposite direction. Newton's third law.